হ্যালো, গুড ইভিনিং এভরিওয়ান। আমি সানিয়া নিয়ে চলে এসেছি ফেনলস। আজকে আমি সকাল সকাল পোস্ট করতে পারিনি কারণ আজকে আমাদের ঈদ ছিল, সো একটু বিজি হয়ে পড়েছিলাম। তো সব কিছু কমপ্লিট অ্যান্ড আমরা শুরু করব আমাদের চ্যাপ্টার, আমাদের টার্গেট। সো ফেনলস স্টার্ট করি। Introduction. Phenol or benzoyl consists of two parts, an aryl group and a hydroxyl group. It is an aromatic organic compound with the molecular formula C6H5OH. It is a white crystalline solid that is volatile. Phenol, also known as carbolic acid, was first isolated in the early 19th century from coal tar. Nowadays, phenol is commercially produced synthetically. Isomerism substituted phenols may exhibit positional and functional isomerism. Position isomerism, all three are position isomerism. There is a orthostresol, metastresol, and parastresol. Dihydric phenol are the example of position isomers. 1,2-benzene diol, 1,3-benzene diol, 1,4-benzene diol. Catechol, resorcinol, hydroquinone. Trihydric phenol also shows position isomerism. This is a diagram shows position isomerism. Functional isomerism, all three are functional isomerism. Method of preparation. Phenols are prepared from benzene derived by any of the following method. From haloarin DOS process. This is a process, haloarin DOS process. From diazonium salt. This is a diazonium salt process. From benzene as sulfonic acid. Reagent is benzene sulfonic acid. From Seumann, phenol is manufactured from Seumann isopropyl benzene. This is a from Seumann reagent. Preparation of phenol. Here, physical properties. Physical properties, boiling point. The boiling point of alcohol and phenol increase with increase in number of carbon atoms, increase in van der Waals force. In alcohol, the boiling point decreases with increases of branching in carbon chain because of decreases in van der Waals forces with decrease in surface area. The OH group in alcohol and phenols involved intermolecular hydrogen bonding as shown below. This is the intermolecular hydrogen bonding. Boiling point of alcohol and phenol are higher in comparison to other classes of compound, namely hydrocarbon, ether, haloalkane, and haloarine are comparable molecular masses. Ethanol, methoxymethane, propane. Molecular mass boiling point 46 by 351 K. Molecular mass by boiling point, this is the haloalkane 46 by 248 K. This is the haloarenes. Propane molecular mass boiling point 44 by 231 K. The high boiling point of alcohol are mainly due to the presence of intermolecular hydrogen bonding in them, which is lacking in ether and hydrocarbon. Solubility of alcohol and phenols in water is due to their ability to form hydrogen bonds with water molecule. The solubility decreases with increases in size of alkyl aryl groups. Several of the lower molecular mass alcohol are miscible with the water into the proportion. Chemical properties. Acidic nature of phenol. Alcohol and phenols react with active metals like Na, K, Al, etc. to liberate hydrogen gas. 2ROH plus 2Na is equal to 2RONA plus H2. 2C6H5OH plus 2Na 6H5ONA plus H2. Phenols also react with aqueous NaOH solution to produce the salt sodium hydroxide and water C6H5OH plus NaOH C6H5ONA plus H2. Nature of phenols is due to the polar nature of OH group. Electron releasing groups like alkyl groups increases the electron density on oxygen and decreases polarity of OH bond. These decrease the acidic strength. The order of acidic strength is here. This is the order. Even through the electron raising group like CH3C2H5 PTC decreases the acidic strength of phenol. Phenol does not liberate CO2 with Na2CO3 and NSHCO3 because phenol is weakly acidic than carbonic acid and carboxylic acid. Relative acid strength: carboxylic acid, carbonic acid, phenol, methyl alcohol, water, others alcohol. The reaction of phenols with metal as well as NaOH indicated that phenol is relatively more acidic than alcohol and also water. This is explained on the basis of structure of phenol. The hydroxy group in phenol is directly attached to carbon of benzene ring. The sp2 carbon attached to O being more electronegative than carbon of alcohol. It decreases the electron density on oxygen because the oxygen develops still more electron-seeking character and release proton by taking in the shared pair of electron with it. The acid nature phenol can also be explained on the basis of resonance stabilization of phenoxide ion. Electron withdrawing groups on phenol increases the acidic nature. Electron releasing group on phenol decreases the acidity of phenols. Acidic strength increases with the decreases of the pKa values. Order of the acidic strength of the phenols is as follows: picric acid 3,5-dinitrophenol, para nitrophenol. pKa values of some phenols and ethanol. Here is a table. Purification of phenol. Phenol react with carboxylic acid and their derivative like acid, chloride, and anhydride to form ester. The reaction is called Schotten-Baumann reaction. C6H5OH plus RCOH to C6H5OCOR plus H2O. This is the reagent pyridine. Reaction with acid chloride is carried out in the presence of a base. Of acid chloride is carried out in the presence of the base so as to neutralize HCl, which is formed during the reaction. It shifts the equilibrium to the right hand side. Salicylic acid on acetylation gives acetyl salicylic acid known as aspirin. Acetyl salicylic aspirin. Reaction of phenol. Electrophilic aromatic substitution. In phenols, OH group is ring activating and orthopara reacting as this position get more electron density through resonance. This is the nitration. Orthopara isomers can be separated by steam distillation. Orthonitrophenol is steam volatile due to intermolecular hydrogen bond. Paranitrophenol is less volatile due to intermolecular hydrogen bond. Phenol, when treated with concentrate HNO3, gives 2,4,6 trinitrophenol known as picric acid. Picric acid. The yield is the reaction is poor. Nowadays, picric acid is prepared by treating phenol with concentration H2SO4 and then the concentration HNO3. Halogenation. When the reaction is carried out, the solvents of low polarity such as CaCl3 or CS2 and low temperature monobromophenols are formed. Here no use acid like FeBr3 are required because highly activating effect of OH group polarize bromine quickly. Phenol react with bromine water and gives 2,4,6 tribromophenol. In water, phenol forms phenoxide ion which activate the benzene ring. Riemann-Tiemann reaction. Phenol, when treated with chloroform in the presence of NaOH, gives salicylaldehyde. This is reaction Riemann-Tiemann reaction. This is a reaction salicylaldehyde. KOH is used. Salicylic acid will be formed. Kolbe's reaction. Phenoxide ion generated by treating phenol with sodium hydroxide are even more reactive than phenol towards electrophilic aromatic substitution. Hence, it undergoes electrophilic substitution with carbon dioxide. A weak electrophile ortho-hydroxybenzoic acid is formed as the main reaction product. Then we start miscellaneous coupling reaction. Coupling reaction in mild basic reaction benzene diazonium chloride react with phenol to form para-hydroxyobenzene. Use of phenol. It is raw material for the manufacture of important dyes, drugs, and pharmac- pharmaceut- uh, pharmaceuticals. 4-chloro-3,5-dimethyl phenol is used as a powerful antiseptic under the name Dettol. It is used in the manufacture of drugs like aspirin, salicylic 0.2% aqueous. Phenol is used as an antiseptic. Phenol on reaction with urea and formaldehyde gives condensation resin used as wood adhesive. Bromine water test, Lieberman test. Thank you for watching our video. আশা করি তোমরা সবাই আমাদের চ্যানেলটাকে সাবস্ক্রাইব করে দেবে পরের ভিডিও পাওয়ার জন্য। ওয়েট করতে হবে একটু, কারণ পরের দিন আমরা কিছু কমার্শিয়াল ইম্পর্ট্যান্ট অ্যালকোহল পড়বো। তো অবশ্যই চ্যানেলটাকে সাবস্ক্রাইব করে রাখবে।